right, for number 3, we need to first start by setting it equal to 0. So if I add 1 over, and then maybe you might want to rearrange it so that the powers are in order. So if you do that, we're going to put that -2 cosine squared theta out front, that sine theta next, and then plus 1 is equal to 0. If you take a look at that, it looks like you might be able to try to factor, but we can't do split the middle unless both the trig ratios are the same. We have a cosine squared and a sine squared, so that's not going to work. And we can't take out a greatest common factor because I don't have a greatest common factor in common. So this is where the Pythagorean identities come into play. So if you recall, or if you look at the top of your quiz review, cosine squared is equal to 1 minus sine squared. So because they are equivalent, we can just substitute it in. So -2, and then I'm just going to leave those parentheses there for a second. Again, because they are equal, cosine squared is equivalent to 1 minus sine squared. That's why we're allowed to replace it. What that does for us is it gives us everything in this problem that has a trig function on it in terms of sine. So I'm going to go ahead and distribute that -2 now. So we have -2, and then we're going to have plus 2 sine squared theta. And this sine theta plus 1 hasn't changed. Before I try to factor, I'm going to go ahead and combine like terms. So this -2 out front can combine with this 1. So we have 2 sine squared theta plus sine theta minus 1 is equal to 0. Now it's up to you. You can continue factoring it with the signs in place, or if you like, you could pick your favorite variable to equal sine and replace it. So I'm going to choose to let x equal sine theta, and that just makes it a little bit easier to factor. There's a little less going on. And you guys have factored so many things that look like 2x squared plus x minus 1. I'm going to go ahead and split the middle. So 2 times -1. And in order to add to give us a positive 1 on the inside, the 1's going to have to be negative and then 2 is positive. So 2x squared minus 1x plus 2x minus 1. Factor by grouping. So I'm going to take out an x, leaving us with 2x minus 1. The second 2 don't have anything in common, so I need to put a 1 as a placeholder, leaving us with the 2x minus 1 in parentheses. So the factored form is going to be x plus 1 and 2x minus 1. Once you get it factored, go ahead and set each factor equal to 0 and solve for x. So for the first factor, we're going to get x equal to -1. From the second factor, we're going to get x equal to 1/2. All right, once you get x by itself, go back and look for this statement where you said what x was equal to. That's an important one. And we need to go back and replace the x with what we said it was to begin with. So we said that it was sine. So now we're looking for, where does sine of theta equal -1, and where does sine of theta equal 1/2? So if you recall, sine is your y-coordinate, and y is going to be -1 down here at 3 pi over 2. And that's the only place where sine is -1. Onto the other one where sine is 1/2. So your y-coordinates are going to be 1/2 at the over 6's, and sine is positive in the first and the second quadrant. So pi over 6 and 5 pi over 6. If the directions just said solve it between 0 and 2 pi, those 3 angles would be your final solution. The directions for this say write the general formula. So we just have to take it a step further. 3 pi over 2, again, is down here, and that's the only angle that works for when sine is -1. So in order to get another angle that would be coterminal and solve that equation for us, we'd have to go all the way around the circle or 2 pi around the circle from 3 pi over 2 to get another answer. The other two, pi over 6 and 5 pi over 6, those are not pi apart from one another. So that's where we keep both angles and say that you have to add 2 pi onto each of them to get more coterminal angles that will work for this solution.